Hello, everyone. Hello. It's great to, well, it's not great to not be there with you. Unfortunately, I had to change my plans last minute, 2 hours before my flight, basically. But anyway, I'm here. You're here. Um, I'll just pretend that I'm with you. And when I ask who likes cooking, you raise hands and I'll say, oh, 72% of you raised hands. Awesome. Great. And I presume you also do read recipe blogs on occasion when you are doing your cooking, because it's very relevant, especially because we'll start with a little question, trick question actually. What do cooking blogs and Android development have in common? But don't worry, I'm not going to answer this right away. I am going to leave this until the end of the presentation to answer it. But yeah, have a think. And while we do that, let's start with a little story. I like cooking, obviously, hence the title and all of that. And when I'm cooking a new dish, for example, a kedgeree, it's like a fusion dish of Indian and Scottish cuisines, basically a curry which has Scottish smoked fish in it. It's super easy to prepare. It takes half an hour, and my kids loves it. So it's super useful to make on a weekday. And when I was first hearing about this, I wanted to make this dish, obviously. And what did I do? I Googled the recipe. So I went online, found the first site that looked okay, and I started reading it. And 10 minutes later, I was reading about this story of this writer, how they went on a motorcycle trip across the Scottish Highlands. And yeah, it took me about 10 minutes to get to the actual recipe after all of that prose that I was kind of going through. And I'm pretty sure that you can relate if you've ever encountered a cooking recipe on a blog somewhere. And this is super annoying because obviously you have to keep your attention to find the actual recipe instead of just landing on it, and B, if you want to get back to it, it's easy to miss different things. It's hard to actually keep track of the whole thing, especially if you're doing it on multiple times. And but there is a good reason, or a couple of reasons, why they do this, the cooking authors. Number one is recipes, unfortunately, are not copyrightable. If you just post a list of steps online, anyone can just take them, copy them, and it's no way you can enforce the copyright. But on the other hand, stories are. So that's why a lot of authors will create stories out of the recipes, so that the whole thing is treated as a story, and then they can copyright them, and they can actually press copyright claims if someone actually plagiarizes their work. Annoying, but that's the world we live in. The other one is has to do with the fact that they are content creators, and content creators want to get discovered, especially if they rely on searches for people to discover their content. So for my example, I was looking for this dish, and I was searching on Google to find it. That's why they kind of have to write these long form prose texts, and that's why they need to get all the keywords in place so that they rank higher on search engines. Again, none of those things make it easier for you to actually parse different recipes. On the other hand, we have recipe books, which contain recipes that are much easier to track and much nicer, have much nicer UX once you have an actual book in your hand to follow it. But yeah, reasons. Speaking of reasons why we can't have nice things, my name is Zan Markan. I'm a developer advocate at Circle CI, and I do like cooking, and I like to eat good food and make good food and discover new dishes. And I'll be taking you on this culinary journey today. So cooking recipes and pipelines. I work for a CI/CD company. We deal with CI/CD pipelines. They actually have quite a lot of stuff in common. First off, they are essentially recipes. They let you encode in steps what you are actually building and how you're building so that you can refer to it later or other people can refer to it later, whether you're working as part of a small team, whether you're working as part of a team of teams that are working on together on a single application. It's a lot easier if you have the whole thing encoded and written down and then automatically executed by a machine rather than having it written down in prose and then followed manually, basically. Or on the other hand, you can even benefit from it if you're an individual developer working on a side hobby project and only have time to work on it every 3-6 months because, you know, tools developed, new versions are released, and you'll forget about different processes unless you have them encoded. That's why pipelines help us in the same way that recipes help you as a cook to make good food. So yeah, what the recipe we will be following today is a build, test, and deploy pipeline for this application called OwnTracks. It's an open source location tracking and sharing app. You can basically use it to track your family location. You can have you can run your own server essentially that's only your family or your friends can access, so that it's very secure, very private, and you can even have it for kids and things like that. It has everything that you need for in like a nice tight pipeline. That's why I quite like it. If you want to go through it, there's links in the talk. I'll share the slides later, but essentially this is the Android app that you can get and you can follow. I wasn't the author, but I helped a little bit on the pipeline, and it has all the cool things that you want. So unit tests, espresso tests, we're sharding the tests. It uses cache in a really nice way for speeding up builds, reports coverage. So if you commit something that kind of drops coverage, it'll let you know. It even automates releases to both Google Play and F-Droid, so the open source free software app store. And it has some neat different flows for contributing, whether you're contributing as a part of the organization or whether you're doing it as an open source fork. They will execute slightly different things based on that. I'll explain the reasons why. Anyway, we are also, it uses Circle CI. I work for Circle CI as a developer advocate, so it's quite neat. And this is basically the leading CI/CD platform out there, and it provides you compute that will execute your pipelines on whatever hardware you might need, whether it's from Docker containers to virtual machines, Windows, Mac, Linux. In our case, we'll be looking at Docker and Linux virtual machines. And then it also has a bunch of other neat things for you, like it helps you collate the results, it helps you analyze the test results, and really collaborate on things as a team a lot better. There's a couple of ingredients that CI/CD tool offers you. First one is this kind of logical distinction of various different components. One of them is is jobs. So a job is a set of steps that execute in a given environment being a virtual machine, a Docker container, an instance of that. So you spin it up, do a bunch of steps. Steps can be, again, scripts that you run, things that you code that you check out. I'll show you the code afterwards, so don't worry about it. Let me just kind of explain a little bit. And if one of those steps within a job, which are supposed to run in sequence, if they terminate incorrectly, so for example, your test fail, the whole thing breaks. You orchestrate those jobs in something called workflows. So similar to cooking, right? You prep your sauce somewhere, you prep your pasta somewhere else, you prep something else, and then you put it all together. And that's a workflow, basically. You say what needs to happen before so that some subsequent job can happen. What are the inputs, outputs, etc., etc., and any conditions that need to be fulfilled. We also have things like triggers. So when should a pipeline run? So when should we execute a recipe? I'll talk about that a bit later as well. And the last thing you need to know is that everything is configured through YAML. We have configuration files that are part of the repository, and they are essentially how we script the whole pipeline. We're one of the sponsors, so if you want to learn more about CircleCI, please do talk to my colleague there, or just reach out to me. My Twitter is @Zan Markan, so yeah, just reach out to me. Anyway, but thing is, with Android especially, you don't really need to worry too much about CI/CD and what tool you're using, because we have this thing called Gradle, and there has been some talks about it already. That's basically your team's own language, and your team should be already familiar with it, because that's how we build our apps anyway. That's how we run our tests. We run our connected checks. We run our tests. We run our lints, all different scripts. We also do things with plugins, for example, for coverage reporting, for Play Store publishing, and all of that. It also comes with this kind of powerful Maven dependencies system, where you basically get all the dependencies together that you can use. That's all done by the framework for you, and you can just take this into any CI/CD tool. So while we'll be looking at CircleCI in particular, most of those things you can just move over onto CircleCI or between different ones. Anyway, it also has a really cool build cache. We'll use that to speed up a bunch of things. So yeah, hopefully most of the ingredients you already have in place for implementing a really tight pipeline for your own application or for your own project. So let's dig in. First off, we'll be looking at a very simple job, or one of the most common jobs that people make when they're building their applications. It's unit testing, it's linting. They're like small, quick, and easy wins that you run, and they are easy to execute. They don't require a lot of resources, and they give you feedback quite quickly. So let's look at the pipeline and see what's what. So I have all these links in this presentation that you can follow that take you to a bunch of different things. So that's a pipeline. I'm hoping you can see this well. I can maybe zoom this a little bit more. It's just a YAML file. You specify the version, and then you declare your executors commands. I'll talk about them a bit later, but we are interested in something called a job, which is called unit test. So in this job, we have a series of steps. So in our case, the interesting one that will actually run our test is called unit test, and it runs a Gradle command. You're familiar with it already, so you know how to do it. In this case, because we're using Jacoco, it's running this not quite the Gradle test command. It's using the Jacoco own command, but essentially that's just wrapping the normal test command. And then before, we still need to check out the code. So we're spinning up a new container. In this case, we're using Docker for this one, because it's quick to spin up and doesn't require a lot of resources. They're cheap and just quick and cheapest option for most things. We need to get the sources in from this particular commit, and then we need to do a bunch of other things. For example, accept the licenses for all the SDKs, This is coming from a Circle CI orb. So it's like a preset series of configs that we offer. And then we need to restore some cache. I'll talk about that a bit later again. But once we've done all of that, we can run our tests, and then we can store those results. And if any of them fail, it would actually notify us as soon as they fail, basically. And we're also persisting and uploading the coverage file into CodeCov, so that if someone opens a PR, it's actually surfaced by this tool. Tell you, hey, something is some coverage has dropped, and this is something that's quite common. So let's look at the executor. So we've basically pulled them out because most of the jobs will reuse these. That's why they're a lot easier to just define as Android-Docker, and that's how you could basically specify the versions. So these are all published. They're Docker images published on Docker Hub. We make those. They're basically made specifically for CI, and they have all the tools that you might need. So Android SDKs, build tools, and also some kind of convenience tools like curl, JQ, etc. That you often need for doing CI related jobs. The other type of executors is the machine images, which we'll use for our UI tests that run Espresso. A bit of them later. So, the lint step is very similar to this. So again, just use the Docker and then run a lint command and then store the artifacts. And how this looks in CI/CD example is basically you have your graph of workflows, and then as we said, we're storing the tests, and this basically surfaces all the test results. This is done automatically, basically, if you have if you're formatting them things as JUnit, but obviously Android is mostly JUnit, so it's very easy. It's very easily done for you. You can even store the actual XMLs as artifacts. And you can see that our unit test job takes 58 seconds, whereas restoring cache, I'll get to that later, takes 27 seconds, but spinning up the actual Docker image only takes 2 seconds, spinning up the container. And that's basically the whole kind of the whole unit test job. Takes a minute and 45. Super quick, super easy. You should have them, at least those, in your apps, so that you get results, you get some feedback from a commit. I hope most of this is not new to anyone, but if it is, please do check it out. This is like the least amount of work you can do to get some really cool feedback out. Now let's look at more interesting types of tests, which are obviously the UI tests. We're using Espresso here. Again, framework you're mostly familiar with, I presume. What's the difference between this and unit testing is obviously they require an emulator, they require a real device. So if you're using an emulator, it needs to run on a device that supports nested virtualization. So not all, like usually Docker executors won't allow that. That's why we're kind of using a VM here. We have special VMs that allow this. And it doesn't need to be done on our one of ours. It can be done on like an external tool. For example, emulator.wtf is like a service, emulator as a service. It's really cool. It actually integrates with Circle CI again, and a bunch of other tools as well. FTL, Firebase Test Lab, if you want to run on different actual test devices, you can do that too. Flank, if you want to parallelize or split your tests across multiple devices, if you have like a long running test suite, that's again a really cool tool for that, used by quite a lot of companies. Because obviously UI tests, they take a long time. That's why we kind of want to split them. So let's look at what a UI test job will actually do. So again, we have a job. here we're using the machine executor. Resource class just specifies, it's a Circle CI thing. It specifies how much resources you're allocating. So how many CPUs, how much RAM. And then we also have parallelism. So basically this will spin up 4 equivalent jobs, which have different environment variables set. So it's got a number of shards variable and shard ID, so that you can know how to actually split them. We'll show that in the actual Gradle script to show you how this is done. Again, you can specify any compiler options that you might want. So Gradle options for compiler strategy. And then we are running our test command. Now, this thing here is coming from an orb. I've kind of alluded this a bit earlier. We have these kind of orbs, which are like utility libraries for CI tools. So Android One is one, CodeCup is another. There's a bunch of other tools. If you're using like Amazon Web Services, you have a bunch of those orbs that kind of simplify your life, or if you're using any other kind of programming tool, like Node.js, for example, has an orb and things like that. And then you have like utility jobs commands that make things a lot faster. So for example, start emulator and run test. It'll basically do everything for you. So you specify what emulator you want, Pixel 3a, 1 gigs of mem, what the test command is in a system image we'll use. So because we're running this as on both the open source and the non-open source, the Google Play versions, we kind of want to have a different system image, one that has Play services, one that doesn't, just to verify that it all works. Where to run the tests, any shell settings. Obviously, they're using a lot of GPS things in there, so that's why we want to make sure that you do that. And then where's it? Yeah, Gradle test command is actually created beforehand, because obviously we need to know what flavor we're actually running against. So create this GMS flavor and or OSS flavor, all the command, and that's obviously what gets executed. And the same with system image. So you basically figure out according to the parameters, and these are like evaluated on the CI itself. This is like the most complex bit of CI configuration that you can have, but it's only for when you have multiple flavors. And then obviously that gets orchestrated in this thing called the workflow, where you basically say, this is flavor, this is the name of the flavor, and what needs to happen. And then obviously we have this in our GMS UI tests, and this is all being run. Then you can see that it's actually figure out the 4 different parallel runs. And as I said, you're passing the parallelism variable, and that then gets used by the Gradle script itself, because Gradle allows you to specify the number of shards and the shard index to kind of automatically build this. So it's super neat to get this out of the box. So you get like 4 different parallel runs, which significantly speed up your tests. So yeah, that's kind of how the UI tests work. We have another UI test job that I'll talk about a bit later, but for now, that's about it. And then last thing we want to do when everything passes, if we're looking at our workflow, is we want to do a publish. So for publishing, everything is done by a plugin. So Gradle Play Publisher from T. It's widely used, and I'm sure a few of you or many of you have already seen this or used it. So this will basically just do everything for you. And the job is essentially just running this before also just making sure that you're kind of getting all the account credentials out of the kind of encrypted environment variables. So this is the security bit that is super relevant, super important. So whenever you are running workloads on CI, you can basically move any secrets out of your repository. I hope you have moved all the secrets out of your repository anyway, but this allows you to do things like account credentials, key store, encrypt them, and only use them in this job whenever it needs to be used. And so this is basically taking these kind of long JSONs and base 64 encoding and creating those kind of JKS and the JSON file that Google Cloud needs, that then the Gradle script is looking for. And this obviously publishes a new release every single time you you commit to master. And this again works on every Play Store, every different store. So if you have Play Store, if you have App Gallery, if you have Amazon App Store, they have their own plugins. It all works pretty much the same way. F-Droid is a bit different. They have their own publishing mechanism. It uses GitHub's own issues, GitHub releases to actually trigger it, but ultimately it's a similar kind of flow. Again, a single job. But now we are getting on how to actually orchestrate these things. Orchestrating is important because we get to do things like that. So we build and then we run a bunch of tests, and then we run a bunch of scans, and then only then when everything passes, we are able to publish this to a store. And we do this by building this kind of graph of jobs that are orchestrated within a workflow. You'll also see that we have a single build job that happens beforehand, which builds all the artifacts that we need. And again, that happens in a Docker container, and then runs all the assembles that we need. And then does the save Gradle cache, which I'll explain now. So we're utilizing, or this project is utilizing Gradle cache a lot to store and restore things, so that instead of adding 6 minutes to every single one of these, this is just like some things happening like 2 minutes or 1 minute 45. So it's really speeding up things significantly. And how this actually works. So when we are starting a job, we're calling this command called restore Gradle cache. And that basically looks at all the build files that you have. So all the Gradle build files, which contain all the dependencies. In this case, dependencies are actually split in a separate toml, but ultimately it could be a single file or multiple files, doesn't really matter. Creating a checksum of all these files, and basically using that as a key of the cache. So so our cache will look, or cache key looks like something like Gradle v4 version is how you really easily flush caches if you have if you've made some changes architecture, so like this kind of Docker environment. And then a build script, so the checksum of this build script. And then we're also doing a checksum of sources. Now this is a bit weird in some cases, but if you are doing a lot of changes in a CI/CD pipeline, you're mostly changing the script, but you don't really need to refresh the sources, so you can just kind of reuse the same caches every single time. And basically it's just doing the same thing for all the Kotlin files, all the Java files in there, and creating a single checksum. and then save Gradle cache. Again, takes these files, so Gradle caches Gradle wrapper, and saves them as this key. And when you come into this kind of restore cache, which is like a built into Circle CI kind of thing, looks into our own kind of cache mechanism, it will look for the first matching key. So you kind of go specific and then less specific, less specific, less specific. So so if your sources have changed, you can still reuse the build file, build script caches. If sources have not changed, you'll get everything. So it's quite handy. And as I said, you will be saving like 1.2 gigs of cache, or reusing 1.2 gigs of cache each single time. And yeah, this allows you to do stuff like that. Really, really handy. And because we're doing that, we can also, sorry, let me just go back to here. We can also do have our workflow, which kind of has all these kind of requirements, and build our graph like this. So in this case, unit testing and linting and scanning for the open source submission are in this kind of first stage after build, and only if these pass, we will continue on to the 2 types of UI tests. Just because they're expensive, they take a long time. You want your feedback as soon as possible. If you are working on a commercial project, you might do all the tests at once and kind of have that extra 2 minutes back, basically. And ultimately, yeah, publish to Play Store requires all the tests to have passed with these credentials. And this is like an example of a pipeline, which kind of lets you orchestrate things nicely. I mentioned triggers. So most of the time you will run CI is on every single commit. So you want to run some tests on every single time you commit, but that doesn't necessarily need to happen every single time. Sometimes you want to do different workflows depending on what's actually been committed. So for example, if we've created a tag like a release, then we can actually filter those tags and make like a beta promotion or production promotion on the same thing. So very similar, but capturing different things. Or you can, if you have like a long running test suite, you can even run them on schedule. So have like a weekly, nightly builds. That's very common, to be honest, that are run on a schedule, that are basically triggered externally from or outside of the kind of VCS commit push cycle. So, but you still get some really nice test results in the morning when you get back to work to see, yes, my work is still passing, or I've actually had a degradation. Let's look at it, especially if you have a very long running test suites, comprehensive test suites, you can do that. As this is an open source project, we have to consider a few other things. For example, there might be an internal group of people who are maintaining this project, and there might be obviously the wider world of people who want to make a fork and a pull request to make a small contribution. This is great because it allows a lot of people to contribute, but it could also hit you a lot because you could be running all those kind of expensive UI tests if you're not careful. That's why we kind of change different types of flow depending on where they are. So, so this, in this case, this is like a regular build and test flow for internal contributors. But if someone were to make a fork, we could actually evaluate this OSS contribution, which would only run the unit test lint, the droid scanner, and and a smoke test, which is like a subset of all the tests that only runs tests for a particular annotation. So like 2 or 3 tests, I think they have in there to make sure the app doesn't crash on startup. And that's pretty much it. So again, quite handy, quite useful, especially if you want to speed up a lot of things. What we have to do this is called dynamic configuration, which basically pre-evaluates a pipeline when we're starting it. Actually, let me go to my pipeline. So you can see in here in this kind of dashboard that we've run this always run workflow, which checks if the PR is forked. And that's like a very quick 5-second job in this case, which just checks the repository name if it's like a built-in environment variable. And if so, you inject this kind of OSS contribution flow as a pipeline parameter, which is then passed to this kind of like continuation pipeline, which with these parameters. And that's essentially the pipeline I was showing you all the time, all along. And basically we've got these parameters defaults to false. So by default, it's an internal flow. But if it is indeed an external contribution, it will toggle this to true. And my workflow, this workflow will start instead of this one which has like a when not kind of thing. And this is basically a really nice tight pipeline. I like how it covers pretty much everything. I know it's a lot. We've kind of went really fast. And I don't think we have time for many questions, but if you do have any questions, please do get in touch with me. I'm quite active on Twitter, on various Android Slack groups, or you can also email me, or if you see me at any events, I'll be very happy, but we've kind of covered a bunch of things. But now, before we finish, I have to answer you the question from the beginning. What do cooking blogs and Android development have in common? It's all Google's fault. And this has been a recipe for a CI/CD pipeline. If you want to see the slides, I can share them with you. Just fill in this form. If you're going to give me any feedback, I would be very appreciative. This is the first time I'm giving this talk, so yeah, I would love it. And if you need any swag, if you want any Circle CI swag, I'll be happy to send it to you as well. By the way, we are also sponsoring the Berlin Droid Lounge that's happening in Seabase tonight at 8 your time. I'm in London, so for me it's a bit 1 hour different. But anyway, check out the Berlin Droid people, or my colleague Jess at the Circle CI booth will give you more details. Anyway, this has been Recipe for a CI/CD Pipeline. I hope you found it useful, and I hope you find the conference great. And that's it. Thank you.